All right, ladies and gentlemen, welcome back to Geometry. We are in Chapter 12, Section 3, and we're looking at volumes of cones today.
Now again, we have a cylinder here and a cone that have the same base area and the same height. So I can fit that in there. Fits exactly inside there. Oh, there we go. Fits in there to the height. Has the same base area. Okay, so the cylinder relates to the cylinder relates to the cone, or the cone to the cylinder, in the same way that a pyramid relates to a prism. And we can have a look at that. Fill this up. Oh, get a little more in there. There we go. All right, that's pretty full. Okay, and again, here, if we look at this, there, notice that's a little below halfway. That is also a third. So, same relation here. The cone relates to the cylinder in the same way that a pyramid relates to a prism. It is one third of the base times the height.
So you can add this to your notes. 1/3 the base times the height, and the base means the area of the base. Okay, so that's the area of the base, which is a circle, and so instead of b, we can use pi r squared. All right? So finding the volume of a cone. All right, remember volume was 1/3 base times the height, and that's 1/3 pi r squared times h. All right, and we know the radius is 2.2, so 1/3 pi times 2.2 squared. This is an oblique cone, but they've given us the height here, 4.5, so that's times 4.5. Now, to be exact, they should have indicated that there's a right angle here, but it appears from the information that they've given us that this should imply the height. So that is 7.26 pi, or approximately 22.81, and that is in centimeters cubed. All right, here we want to find the volume of this cone, and this 5 is not the height, okay? That's the lateral height. So we want to know the height of the cone, but we have a right triangle here, so we can use the Pythagorean theorem. A squared plus b squared equals c squared. And you might recognize this as the Pythagorean triple for 3, 4, 5, but we can go ahead and do that. Now, very important, c is the longest side opposite the right angle. So this side is c, so we'll put the 5 here, 5 squared, and then a squared plus 4 squared, that gives us a squared plus 16 is 25, and so a squared subtract 16 from each side, a squared is equal to 9, find the square root, and a is 3. So the height here is 3. Now we can do 1/3 pi times 3 times 4. That's the volume. 1/3 and 3 cancel out, so that's 4 pi. Or if you want to approximate this, 4 times pi comes out to be about, oh wait, sorry, let me back up. I made a mistake here. Radius squared. So that is 16 pi. There we go. So the volume comes to be about 50.27, and this is in feet cubed. right, finding the volume of a cone. A water tank is shaped like an inverted right cone with a depth of 6 meters and a diameter of 7 meters. Find the amount of water in cubic meters the tank can hold. We've got a word problem. Anytime you have a word problem that talks about a shape, I recommend drawing that shape, okay? They say an inverted cone. So we can draw something that looks kind of like an inverted cone. Okay, and it says it has a depth of 6 meters. So go from here down, that's 6. Okay, and then a diameter from one side to the other of 7 meters. Okay, so that's not the radius here, careful, that's the diameter. So we want to find the radius. So the radius is half the diameter. So that is 7 divided by 2, which is 3.5. Okay, and then now that we have the radius, and we can plug this all in, we get volume is 1/3 pi r squared. This time we need to make sure we're squaring it, not to forget that again, 1/3 times pi times, oh, but I'm forgetting the height. Making lots of mistakes here, times the height, there we go, times 3.5 squared times 6, and then we go typety-type, type that in, and you get about 24.5 pi, or approximately 76.97. And this is in meters cubed. All right, similar solids. Again, remember that our scale factor K is always new, I was supposed to say new, over original. New over original, and that the volume relates in a cubed fashion. So if you want to find the volume, you take the scale factor and you cube it. Okay? So here the scale factor, new over original, new being cone B, is 9/3. 9/3, which can be simplified down to 3. So that's our scale factor. Now, if we want to find the volume from the volume to the other, then we have to take that by K cubed times the scale factor cubed. So I'm going to take the volume of the new one, volume B, is volume A times K cubed. So volume B is 15 pi times 3 cubed. 3 cubed is 27. So 15 times 27 is 405 pi. So then we get 405 pi. And since this was given as pi, I can leave that answer as pi, and that is in feet cubed. All right, here we have a composite solid, and we want to find the volume of the whole thing. So we've got a cone on top and a cylinder on the bottom. So we have to find cylinder and then add these two together, right? Add the cone to the cylinder. So the cylinder is pi r squared times the height, and that's the height of the cylinder. Let's do cy, and then plus pi at 1/3 pi r squared times the height of the cone, CO. There we go. Okay, because the height of the cone is different from the height of the cylinder. All right, now we got pi times, the radius is the same on both of these, 6 squared, times height of the cylinder, that's 5, plus 1/3 pi times 6 squared times 4. Okay, this comes out to be 180 pi plus 48 pi, and that gives us a volume of 228 pi, or you can type that in and get approximately 716.28, and that is in meters cubed. There we have it, ladies and gentlemen. Lots of fun with volumes of cones. Check in again next time for more good times with geometry.